The most expensive tank in the world. Is it really as good as they say? 16 million euros for a single combat vehicle. That is exactly how much the French Leclerc tank costs. This makes it the most expensive serial tank on the planet. For this amount of money, you could buy 3 American Abrams or 4 German Leopards. But here is what is interesting. This tank, packed with electronics like a spaceship, has never been in a single serious war. A few skirmishes in the Yemeni desert, where the Houthis shot out its optics with ordinary rifles. That is the extent of the combat experience for the pride of French tank building. So, what are people paying such insane amounts of money for? And why do military experts still argue whether the Leclerc is capable of withstanding a real battle? To understand this, we must go back 80 years to a destroyed and humiliated France, which had just experienced the most terrible catastrophe in its history. The summer of 1944. Paris is finally free, but the country lies in ruins. 4 years of German occupation turned a once great power into a shadow of itself. Yet not long before the war, France was the second tank power in the world, trailing only the Soviet Union. French factories produced hundreds of armored vehicles, and their engineers were considered among the best in Europe. Now, nothing remains of that former greatness. Factories were bombed, blueprints destroyed, and many designers died or fled the country. But the French spirit proved stronger than the occupiers expected. While German soldiers marched down the Champs-Élysées in underground workshops and secret laboratories, French engineers continued to work. They studied captured German equipment, made drawings and calculations, dreaming of the day they could revive domestic tank building. And what is most surprising is that they were inspired specifically by German machines, the very same tanks that had crushed their army in a matter of weeks. It was bitter to admit, but the German engineering school had indeed proven superior, and the French decided to learn from the winners to one day surpass them. Immediately after the liberation of Paris, the provisional government set an ambitious task for the designers: create a heavy tank that would not be inferior to the world's best models. Thus, Project 444 was born. Engineers worked day and night, but the result disappointed everyone. The machine turned out to be bulky, clumsy, and hopelessly outdated even at the blueprint stage. Against the background of the British Centurion, the American Pershing, and the Soviet IS-3, the French tank looked like a cart next to automobiles. The project was shut down, but the designers did not give up. In 1949, work began on a new tank under the designation AMX-50. This was a completely different machine, embodying all the lessons learned from studying German technology. For 9 long years, engineers tried to perfect it. 9 years of testing, refinements, and disappointments. The main problem was the power plant, which refused to work reliably. The engine overheated, broke down, and failed at the most inconvenient moments. By the time these problems were nearly solved, a new project called the AMX-30 appeared, and work on the 50th was discontinued as unnecessary. Meanwhile, a serious discussion flared up at NATO headquarters. Members of the alliance decided to create a single tank for all Western armies. The idea seemed logical: one machine, the same spare parts, one training system. The American M47, which formed the basis of NATO's armored forces, was aging before their eyes and urgently needed a replacement. But the Allies could not reach an agreement. The British wanted a heavy tank with powerful armor capable of withstanding hits from Soviet shells. The Germans and French insisted on a light and maneuverable machine that could move quickly across the battlefield. Each country pulled the blanket over itself, wanting to load its own factories with orders. In the end, the joint project failed, and everyone went their own way. The French army received its AMX-30 tank in 1963. The machine was quite good for its time, fast, maneuverable, and with a powerful gun. But it had one critical flaw that outweighed all its virtues. The gun lacked a stabilization system, meaning the tank could only fire while standing still. In a real battle, where the winner is the one who shoots first, such a tank became an easy target. While the French crew stopped and aimed, a Soviet T-62 would already be slamming a shell into it at full speed. While the French struggled with their AMX-30, something incredible was happening on the other side of Europe. The Soviet Union made a real breakthrough in tank building by releasing 3 new-generation main combat tanks at once: the T-64, T-72, and T-80. Each of them surpassed Western counterparts in key parameters: powerful 125mm smoothbore guns, autoloaders that allowed firing at frantic speeds, and armor capable of withstanding hits from most NATO shells. Soviet tank armadas numbered tens of thousands of machines, ready at any moment to flood through the Fulda Gap into the very heart of Western Europe. Against the background of this steel avalanche, the French AMX-30 looked not just outdated, but frankly helpless. Its 105mm gun struggled to penetrate the frontal armor of the new Soviet machines, and its own protection could not withstand criticism. One lucky shot from a T-72, and the French tank would turn into flaming scrap metal. Military analysts in Paris were tearing their hair out. In the event of a great war, their armored forces were doomed to destruction in the very first hours of the conflict. Things were not much better for other NATO members. In the early 70s, Western countries finally realized the scale of the threat and rushed to catch up. West Germany created the magnificent Leopard 2. The Americans responded with the M1 Abrams. These machines could already fight Soviet tanks on equal terms, but France was lagging again. Its designers were still tinkering with the modernization of the hopelessly outdated AMX-30 instead of creating a fundamentally new machine. In 1978, hope dawned. France and West Germany agreed on the joint development of a third-generation tank. By combining the resources and engineering genius of two nations, they could create a machine superior to everything that existed at that moment. The Germans sent their best specialists to Paris. The French prepared ambitious projects. Cooperation seemed destined for success. But already at the first meetings, it became clear that the partners were looking in different directions. German engineers insisted on creating a heavy machine weighing more than 60 tons. In their opinion, only thick armor could protect the crew from Soviet shells. Even if the tank was slow and clumsy, it would withstand a direct hit and continue the fight. The French categorically objected. They wanted a light and rapid machine capable of evading fire through speed and maneuverability. Why do you need thick armor if the tank can simply prevent itself from being hit? The disputes continued for months. Every meeting ended in mutual accusations and door slamming. The Germans called the French approach suicidal adventurism. The French called the German project a clumsy dinosaur. By 1980, it became finally clear that an agreement would not be reached. The joint project failed miserably, and the former partners went their separate ways to build tanks individually. France was in a desperate position. No state program for creating a new tank existed. There was no money in the budget, and the military continued to receive the morally obsolete AMX-30. At this moment, an unexpected player entered the stage. The largest French defense company, Giat Industries, now called Nexter, grew tired of waiting for a state order and made the daring decision to start developing a revolutionary tank at its own expense, counting on future export contracts. It was a huge risk. Creating a modern tank required colossal investments, and there were no guarantees of success. But the company leadership understood that if they did not act now, French tank building would finally die. The country's best engineers gathered in the design bureau to create a machine that was supposed to surpass the German Leopard, the American Abrams, and all Soviet tanks combined. First came the AMX-32 project. Designers tried to deeply modernize the old AMX-30 by installing a new turret and a modern fire control system. but strict weight restrictions did not allow for a decent level of protection. The tank turned out to be neither fish nor fowl, too heavy for a maneuverable machine and too poorly protected for breaking through defenses. The project was closed, but the developments were saved. The next attempt was designated AMX-40. This time, engineers installed a powerful 120mm smoothbore gun and significantly improved mobility. The machine showed excellent results in tests, but its turret looked outdated, and its protection still lagged behind German and American models. The company organized a massive advertising campaign and took the tank to international exhibitions, but no buyers were found. Another failure, more millions thrown to the wind. However, it was these failures that laid the foundation for future success. Every failed project brought priceless experience. Engineers learned from their mistakes, improved technologies, and gradually moved closer to creating the ideal machine. In 1982, work began on a completely new tank under the code name Engine Principal de Combat, which translates to main battle machine. This project incorporated all the best from previous developments and added revolutionary technologies the world had not yet seen. 4 years of intense work, hundreds of tests, and thousands of drawings. By the end of the year, 6 prototypes of a completely new combat vehicle stood at the Guyot Industries test site. Externally, they resembled the German Leopard 2. But under the armor lay technologies that no serial tank in the Western world had ever seen. That same year, the machine received its name in honor of Marshal Philippe Leclerc, the liberator of Paris from German occupation. A symbolic choice for a tank that was meant to revive the glory of French tank building. The first thing that stood out when getting to know the Leclerc was its armor. French engineers developed a unique modular protection system that had no analogs in the world. Removable elements of multi-layered armor were attached to the hull frame using special anchors. It consisted of steel, Kevlar, and ceramic materials arranged in layers in a strictly defined sequence. Each material performed its own function. Steel stopped fragments, ceramics destroyed the cores of armor-piercing shells, and Kevlar absorbed the impact energy. The genius of this system lay in its practicality. If an enemy shell damaged one of the modules, the crew could replace it right in the field without sending the tank to the factory. Moreover, as armor technology developed, outdated modules could be replaced with more advanced ones, constantly increasing the vehicle's protection. No other tank of that time possessed such flexibility. The creators of the Leclerc claimed that the frontal projection protection against sub-caliber shells was twice that of other NATO tanks. A bold statement that was impossible to verify without real combat tests. The technical specifications stated that the armor must withstand hits from Soviet 125mm armor-piercing shells and prospective 130mm cumulative munitions. Whether the engineers achieved this goal remains a military secret to this day. Designers paid special attention to protecting the turret roof. The fact is that in the 80s, anti-tank missile systems attacking the target from above were developing rapidly. The American Javelin and the Swedish Bill were capable of hitting tanks in the most vulnerable spot, where armor was traditionally thinnest. The French took this threat into account and seriously reinforced the upper projection of the turret. According to their claims, the roof could withstand hits from 30mm armor-piercing shells and RPG-type anti-tank grenades. At the same time, the Leclerc became the only modern tank that completely lacked explosive reactive armor. These small containers of explosives, installed on top of the main armor, were used on all Soviet tanks and were gradually appearing on Western machines. When hit by a cumulative shell, they would explode outward, destroying the cumulative jet. An effective and relatively cheap technology, but the French refused it. The reason lay in the tactics of use. French military doctrine presupposed close interaction between tanks and infantry. Soldiers were supposed to advance alongside the armored vehicles, covering them from grenadiers and correcting fire. but the activation of reactive armor was accompanied by a powerful spray of fragments, deadly to everyone nearby. Choosing between additional tank protection and the safety of their own infantry, the French chose the infantry. The main weapon of the Leclerc was a 120mm smoothbore gun with a barrel length of 52 calibers. This gun surpassed its counterparts on the Abrams and Leopard in all key parameters. The longer barrel accelerated the shell to an initial speed of 1,750 meters per second, which provided better armor penetration at all combat distances. The barrel resource was 400 shots, after which it could be replaced within an hour without dismantling the turret. But the real revolution was the autoloader. The Leclerc became the first serial tank of Western countries equipped with this device. Before that, autoloaders were considered the hallmark of the Soviet school of tank building. Western militaries were skeptical of them, preferring a live loader who could assist the crew with other tasks. But the French decided to take the risk. The autoloader was located in the rear niche of the turret and worked on the basis of a belt conveyor. 22 shells were in constant readiness for loading. Another 18 were stored in a drum-type ammunition rack inside the hull. The mechanism provided a rate of fire of up to 12 rounds per minute, regardless of whether the tank was standing still or rushing over rough terrain at full speed. Taking into account aiming time, the crew could hit up to 6 targets per minute, which was an absolute record among all the world's tanks. Thanks to the autoloader, the Leclerc's crew was reduced to 3 people: a commander, a gunner, and a driver. This had a huge impact on the vehicle's layout. Fewer people meant a smaller armored volume, which meant less mass for the same armor thickness or greater protection for the same mass. The French chose the golden mean. The Leclerc weighed only 54 tons, making it the lightest third-generation main battle tank. Next to the gun was a 12.7mm Browning heavy machine gun. This was an atypical solution for NATO tanks, where the coaxial machine gun usually had a rifle caliber. But the French reasoned differently. The powerful Browning could be used as a ranging weapon. Its bullets maintained a trajectory similar to the shell at distances up to 600 meters. And in battle against light-armored vehicles and manpower, the heavy machine gun was far more effective than its small-caliber counterpart. In addition to armor and armament, the Leclerc received another secret weapon that could not be seen from the outside. French engineers packed the tank so tightly with electronics that the machine resembled a combat aircraft more than ground equipment. All fire control systems, including gunner and commander sights, thermal imagers, a laser rangefinder, a weapon stabilizer, and a digital ballistic computer, were integrated into a single electronic computing complex. The computer automatically calculated firing parameters, taking into account air temperature, atmospheric pressure, wind speed, and even the curvature of the gun barrel from intense firing. The tank information and management system received a voice module that spoke to the crew in a human voice. Imagine a battle. Explosions are thundering, the driver is maneuvering between craters, and the gunner is catching enemy vehicles in the sight. In such an environment, it is easy to miss a flashing indicator on the dashboard, but it is impossible to miss a voice shouting in your ear about engine overheating or running out of ammunition. This system prevented the loss of critically important information during the most intense moments of battle. The Leclerc's radio station could convert messages into digital and graphic formats. In conditions where the enemy jams radio communications, this became a real lifesaver. If a voice message did not get through the interference, the system automatically translated it into text and sent it as a digital packet. The tank commander could draw a diagram of the enemy's location on a special screen and instantly transmit it to headquarters. This was faster and clearer than explaining with words under the roar of cannonade. But that's not all. The radio used frequency hopping technology. Every second, the transmission frequency changed according to a preset algorithm known only to friendly forces. An enemy trying to pinpoint the tank by radio signal received only fragments on different frequencies that could not be assembled together. Finding a Leclerc by its radio transmissions became a practically impossible task. All data collected by the tank's electronics were transmitted in real time to the command post. Unit commanders saw on their screens the position of each machine, its course of movement, technical condition, and remaining ammunition and fuel. This allowed for the coordination of tank group actions with a precision unattainable for armies relying on voice communication. French generals received a picture of the battle that their colleagues from other countries could only dream of. The tank was operated via a fly-by-wire scheme, similar to how modern fighters were handled. There were no cables or rods between the levers and mechanisms. The driver's movements were read by sensors and transmitted to the executive devices by electrical signals. To start the engine, it was enough to press one button instead of the complex procedure that took several minutes on previous generation tanks. The heart of the Leclerc was a compact 8-cylinder diesel engine with 1,500 horsepower. With a mass of only 1,600 kilograms and a working volume of 16.5 liters, it provided a specific power of 27.5 horsepower per ton of weight. This was the best figure among all third-generation main battle tanks. For comparison, the gas turbine engine of the American Abrams produced only 24.5 horsepower per ton, and the German Leopard 2 even less. The secret of such power lay in the hyperbar supercharging system. It increased pressure in the cylinders, raising power and torque without increasing the engine's size. In addition, the system could work as an auxiliary power source with the main engine turned off. The tank could stand in ambush for hours with its electronics running without giving itself away with engine roar and thermal radiation. The test results were staggering. The Leclerc accelerated to 32 kilometers per hour in just 5 seconds. The maximum speed on the highway reached 71 kilometers per hour. Fuel tanks held 1,300 liters, which was enough for a 550-kilometer range. Installing 2 additional tanks in the rear increased the fuel supply by another 400 liters and the range to 650 kilometers. However, they had to be dropped before battle as they restricted turret rotation. Serial production began in 1991. The French Army planned to buy 1,400 machines, but the Cold War suddenly ended. The Soviet Union collapsed. The threat of tank armadas breaking through the Fulda Gap vanished. Military budgets across Europe were cut ruthlessly. The original order was reduced first to 612 units and then finally to 406 tanks. Giat Industries, which had invested colossal funds in development, was on the brink of bankruptcy. Salvation came from an unexpected direction. In 1993, the United Arab Emirates signed a contract for the purchase of 438 Leclerc tanks and 40 armored recovery vehicles based on it. The oil sheikhs were not deterred by the high price or the fact that the tank still required refinement. In their understanding, the cost of a product spoke to its prestige. The more expensive, the better. 25 years later, in 2018, the German magazine Der Spiegel published an investigation into this deal. It turned out that one of the Arab intermediaries received a commission of $195 million. Journalists suggested that this money could have been used to bribe officials. However, the scandal did not change the main point. The French won a commercial victory and launched export production before they received an order from their own army. Specially for the Arab customers, the French created a modification called the Tropic. Operating a complex combat machine in conditions of extreme heat required serious modifications. Engineers installed a powerful air conditioning system that primarily cooled the fickle electronics rather than the crew. The Leclerc's computers and sensors were its main advantage, but also its main weakness. If they overheated, they would fail, turning the tank into a pile of useless metal. The basic French engine was replaced with a German MTU 883. This motor showed higher reliability when working in the scorching desert, where air temperatures rose above 50 degrees. Equipment for underwater driving was dismantled as unnecessary, since rivers were rare in the sands of the Arabian Peninsula. On the other hand, a remote-controlled combat module with a machine gun appeared on the turret roof, allowing fire on enemy infantry without sticking out of the hatch under the scorching sun. In 2006, at an international arms exhibition, France presented another modification called the Azur. This version was intended for fighting in urban areas, where tanks traditionally suffered heavy losses from grenadiers hiding in windows and basements. Additional modules of composite armor were installed on the hull sides, and the rear and back parts were covered with anti-cumulative slats. A special armored plate protected the vulnerable cooling system grills from Molotov cocktails, which partisans liked to throw onto the engine compartment roof. The Galax system was expanded with a new type of ammunition. Now, in addition to smoke grenades, it could fire fragmentation ones, producing hundreds of lethal fragments in a radius of 15 to 30 meters around the tank. If an enemy infantryman got too close with a grenade launcher, the crew could turn the space around the machine into a zone of total destruction with one click of a button. Cruel, but effective. Proximity detectors were placed around the hull perimeter. In narrow city streets, tankers often did not notice threats creeping from blind spots inaccessible to optical instruments. Now, electronics warned the crew of any movement near the machine, whether it was an enemy soldier or just a stray dog. It was better to be alert than to take a grenade to the side. Instead of additional fuel tanks in the rear, light armored boxes were installed for storing supplies and ammunition. During prolonged street battles, infantry could use the tank as a mobile supply point, replenishing ammunition right on the front line. All these modifications added several tons to the vehicle's mass and reduced its mobility. But the developers rightly reasoned that speed and maneuverability do not have a decisive role in narrow alleys. To date, there are only 3 countries operating Leclercs. France has 406 tanks, of which 222 are in service and the remaining 184 are in storage. The United Arab Emirates operates 354 machines, which form the basis of the country's armored forces. Jordan received 80 tanks as a gift from their generous Emirati neighbors. The only real combat use of the Leclerc was the war in Yemen. The United Arab Emirates Army deployed at least 70 machines as part of the coalition forces fighting against the Houthi rebels. And here, the pride of French tank building faced unexpected problems that were not written about in advertising brochures. The Houthis quickly realized that a frontal attack on the Leclerc was pointless. Instead, they began systematically shelling the tank's external optics with regular sniper rifles. The sights, cameras, and sensors that made up the eyes and ears of the machine proved vulnerable to accurate rifle fire. A blinded tank lost most of its advantages, turning from a high-tech hunter into a clumsy target. Things were even worse with the engines. The finest sand and dust of the Yemeni desert penetrated the engine compartment, clogging filters and accumulating inside the units. Despite the special adaptation for hot climates, the power plants began to malfunction after several weeks of intense operation. Several machines failed due to engine problems in the midst of combat operations. In 2024, France presented the latest modification called the Leclerc Evolution. The manufacturer stated that this prototype already belongs to the 4th generation of main battle tanks. The machine was armed with a new Ascalon smoothbore gun of French manufacture. The gun is produced in 2 versions, the traditional NATO caliber of 120 millimeters and a prospective caliber of 140 millimeters, which should become the standard for Western tanks in the future. A feature of this gun is the ability to replace the barrel from a smaller caliber to a larger one right in the field in less than an hour, and without dismantling the turret. Taking into account the experience of modern conflicts, a remote-controlled combat module with a 30mm automatic cannon and a radar air target detection system was installed on the turret roof. This module is capable of hitting not only ground targets, but also small drones at distances up to 1,500 meters. The rate of fire reaches 720 rounds per minute in accelerated mode, and special munitions with remote detonation explode near a flying drone, hitting it with a cloud of fragments. A container with 3 loitering munitions was placed on the hull, turning the tank into a mobile strike system. Now the crew can destroy targets far beyond direct visibility without exposing themselves to return fire. With the addition of all these systems, the load on the 3 tankers became unbearable, so a 4th person was returned to the crew. He was placed in the spot where part of the ammunition rack used to be. 16 million euros for one machine. The most expensive, the most high-tech, and the most unproven tank on the planet. The Leclerc is still waiting for its moment to prove that it is worth every Eurocent spent. If you like this story, like and subscribe to the channel so you don't miss new episodes. Write in the comments which piece of equipment to analyze next, and I will definitely make a detailed episode about it.